So good morning to all. Now we are ready to start our first session of this course. So I am just going to give you some introduction about the cyber security. What are the objectives of cyber security? What are the various types of attacks possible? And later on the standard parts, that is IC 61850 and some other standards like C37, IEEE C37.11a, that will be covered by Professor Sidhu in his upcoming lectures. So today and today 3 hours, and maybe after that the next days. So if we just go ahead, what is cyber security? So cyber security is nothing but it is a type of the practice to defend our computers, our networks, our smart devices, so called, all the electrical and electronic systems, and the main thing is our data, because data, today, whether we talk about the our grid, or we talk about the distribution side data, like data gathered by the smart meters, or the data gathered at EVSC, that is electric vehicle station equipment, because now we know that the government is encouraging the use of electric vehicles, and when we go for charging of electric vehicles at the center, right, at the station, so there also the stations are going to gather the data through some protocols, right, that is OCPP protocols, open charge point protocol. So those things are also very important. So if we just look at what are the main objectives of or the pillars of cyber security, then there are three major objectives of cyber security. One is known as confidentiality, the second one is the integrity, and third is the availability. Now if we go from the first one, confidentiality, then it is nothing but we want to preserve the information what is available, right? We have, that means only the authorized user gets the access of those information. Others who are not authorized, they do not have the access to have the to access for that data, or whatever is the information we have. So that is one thing. And so basically the major objective of the confidentiality of cyber security is to protect our the personal privacy and proprietary information. So per personal privacy and proprietary part, that is very important, right? For any type of data, any type of smart devices, when they communicate with other smart devices, they send data. So those only authorized users, or whatever the let's say engineers are there who are authorized to have the data, only they are able to observe or get the access of those data. The second one is the integrity. So integrity is related to the gardening against improper information modification, or sometimes destruction also. So we know that whenever any attacker is there, any attacker is present in the system, then they try to modify the information, or they try to remove or destruct or manipulate those information or data. So that we want to avoid it. So that is not, that comes under the integrity part. And here in integrity, the objective is to ensure the information non reproducible especially in particular system or particular area. Now, if we just look at the one by one, the each attack. So if we start from the malware type of attack, so this type of attack that was done by some software part. So what the attacker does, attacker is going to introduce some software through some devices like USB or some that type of devices which you put or plug in your computer. So this is that type of attack. And this type of attack, when it is executed by an attacker, the unauthorized action on the victim system that is to be taken place. So they may try to manipulate the data, they may try to hack the data. So such type of incidents were observed also. They were quoted by various papers also in past. The second type of attack is the phishing type of attack. This type of attack is usually, it is an engineering attack, and it is usually done by sending an email. So we know that even though we have a Cisco system at IIT Roorkee, we are getting several emails, right? That even sometimes you are getting emails from head of the department also, right? But it seems that they are not the actual mails sent by head of the department. Someone else who has done such type of, or who has sent such type of emails. So this is known as phishing type of attack. And the major objective of this type of attack is to steal the, let's say, information like the data, maybe the credentials of your credit cards or anything, or maybe UPI also they try to steal from your system or from your cell phone. So this is also such type of attack. The third type of attack is known as spear phishing type of attack. This is also usually done through by sending an email to your system. And the specific target for this attack, which was observed in the papers and by the industry also, that is a specific individual or some business firm or a big organization firm. So this was done. You know, last time recently you observed, I think 2 weeks ago there was an attack at Delhi airport. Though government claimed that it was the problem in the software handled by the Airport Authority of India Delhi region, but it was a cyber attack, right? So yeah, anyway, government has not accepted, but the many newspapers and many channels quoted that it was an attack, right? So it was the this type of attack that someone has injected some emails, some data, or some malware through emails, and then the entire system was crashed for 24 hours. I think more than 300 flights were delayed, right? Even I was the witness because I was traveling, and my flight was also get delayed around 5 hours, more than 5 hours. So it was an attack also, and it was done through this type of spear phishing emails. Then the other variety of attack, that is known as man in the middle type of attack. So here the speciality of this attack is that the attacker tries to alter or change the communication between two parties. Let's say we have one party X, another party Y, and X is communicating with Y. But when attacker comes in picture, the X still assumes that okay, I am communicating with Y, nobody else is watching my activities. But attacker comes in picture and he is going to watch the communication between X and Y and X. So secretly, the attacker is observing or watching this type of activities. Like for example, we have the the PhD systems, online systems available in our campus, right? Through which most of the MTech and PhD students, they are submitting progress report and special SRC forms, all those. Now someone else, yeah, only the your supervisor is let's say authorized person who can watch it, or DRC chairman, or at the time let's say head of the department. But if someone else has a credential, right, and you know that those credentials are beautifully let's say created by our academic affairs system, that anyone can hack it very easily, right? Even I can show the demo also, but though it is not permitted, but anyone can do that, right? So anyone can log in, let's say on behalf of any student, anyone can log in on behalf of, let's say, Professor CP Gupta or Professor Avik, or right. And anyway, we are, there is nothing to alter, but if you wish you can do that also. So this is also, this can be also done. Like for the best example is our let's say attendance system, right? When any professor is going to take the attendance while conducting the class in lecture hall complex, then we have online attendance system. And the beauty of that attendance system is that its radius is 30 meters. So anybody can, let's say, have the mark the attendance if you are within 30 meters, right? And some of, now they have I don't know, they have increased or decreased the span, I don't know, but I observed that some of the students, they are still marking their attendance sitting in the bhavans, right? It is there, right? I observed. They have done the hacking of this our system also, unless and until you are doing, or any professor is taking the attendance from some specialized software, right? Like some Academy or some other software, then it is slightly difficult. The next type of attack is known as denial of service attack, and this type of attack is very common in our electric grid. So the objective of this attack is, whenever attacker is there, they try to shut down your system for specific period of time. Let's say they try to close or shut down the system for 10 second or 5 second, like that. So for 5 or 10 second, whatever smart devices are there, they are not able to send the data. Let's say for example, we have one smart meter and another smart meter. So one smart meter is sending the data to another smart meter who is receiving, but that receiver and whatever smart meter is there, they are not going to receive the data, even though my sender at sending end, my smart meter is sending the data, but at receiving end, my another smart meter, he is not able to receive those data. So this type of attack is known as denial of service attack, and most the objective of in this attack is to, either you want to shut down the machine or the smart devices, or you have want to shut down the entire network. This was the objective of this type of attack. Then the other type of attack is known as the structured query language type of attack. So here in this type of attack, attacker tries to modify the codes, right? Whatever codes that is run from backend side, right? You know that, let's say for example, when you transfer the data, right, through either through LAN or maybe let's say Wi-Fi or wired network, then from backend side some systems is running, right? Either they transferred through TCP protocol or UDP protocol or any other protocol. So there the attacker tries to modify the codes from the backend side. So we are not able to visualize, let's say someone has done the modification in the code which was run from backend side in the system. The objective of this attack, XQL type of attack, is to just target the sensitive company data. For a best example is our Aadhaar, right? We know that whenever we have anything we want to do it, we are doing all the transactions, bank transactions or UPI transactions through our Aadhaar, right? Because that from Aadhaar, which is linked with that our banking system, we are going to get the OTP. So that if someone is trying to hack that system, then there is an issue. The other type of attack is known as zero-day exploit type of attack. This is also one type of the software attack where the attacker tries to modify the code which was run from the backend side. The next type of attack is known as the advanced persistent threat type of attack. So here also the some unauthorized person, which we can call it the attacker, tries to modify or get the access from the system, uh, assuming that let's say two source and destination is trying to send the information, and when attacker let's say gets involved in that, then the source and destination, they do not know that someone else is also watching the, let's say for example, you are trying to hack the email of someone, right, through let's say IP address. So the person who is sending the emails, they are not aware that, oh, someone else is also watching my emails, right? Sorry. Then we have the DNS type of attack. So this is also the part of the code which is run by the internet infrastructure. So they are trying to modify that code also. The last type of attack that was known as the ransomware. So here this is a special type of attack where the attacker tries to steal the data. They log the data and they try to, let's say, encrypt the files. And when they and after some time they send the, let's say, they put the demand that okay, you give some money, then and then I will give you the data or I will decrypt it. So this type of attack is a specialized type of attack, and usually this type of attack that is done at the point of sale terminal, POS terminal, when we swipe our card, or maybe some, let's say, computer printer or smartphone where you use the network printer. So there this type of attack that is very common. Now why we need cyber security for our electrical system? So there was a survey around 12-13 years ago, and it was done by the US department. It is a US Department of Home and Land Security, and in that survey the this observe it is observed that the 56% of the total attack that was on energy sector. So our energy sector is very vulnerable, right? Because one can easily only what you have to do is you have to simply breach the firewall, and there are many ways. Just you type in Google how to breach the firewall, you will find I think more than 300 ways how to breach the firewall. So this is very common, right? And so attack on energy sector, that is very common. The other sector you can see 18%, that is on manufacturing part, industrial side. That's why the industrial people said that industrial operational technology and information technology both are very important as far as industrial users are concerned. So this is also there, and then slightly 5% on the IT companies are there, and later on as you go further, the attack on the other sectors they are reducing. So our major concern, that is the energy sector, more than 50% attack, and another is the 18%, that is the manufacturing side. Now there let us go what are the types of attacks that was done in past. So the first attack, as you can see from the table, that was done in 2009 on the Iranian nuclear system. It was done through USB drive, and the malware detected was Stuxnet. So it was injected through the USB drive, and the affected parties are your SCADA and PLC systems. So there was a shutdown of SCADA and PLC systems for more than 6 hours. Right? It was reported in that. There was an article available in Google. You can go through it. Then the next attack that was done on Ukrainian power system. It was in December 2015, and here this attack was done by spear phishing emails. So someone has sent the emails, and they injected the black energy 3 malware. You can again go through the article available. So through this the attacker has targeted 30 substations. They have switched off 30 substations. 0.23 million people were affected, and they left electricity for more than 6 hours. So that was the impact of the attack which was done on Ukrainian power system in December 2015. Then cyber attack was done in 2017, which heated more than 150 countries. It was because of ransomware. Uh, then again in USA 2017, three cities was targeted: Los Angeles, San Francisco, and New York City. Malware means what type of attack, that was unknown. Again in Venezuela 2019 it was there, which lasts for 7 days, which causes reported 43 deaths. And then in 2021 it was done on Australian power company. Though company claimed that there was no impact on generation, transmission, and distribution, but again some of the reports claim that uh, there was an impact, right? It was because of the ransomware. So the point is that now how the attack this whatever various attacks which we have seen, how what are the various vectors or equipment through which attacks can be done, right? So if you just look at, I have listed here the various devices. The first device comes, that is the PMU, phasor measurement unit, which nowadays the utility is using, right? For last several years, there was a scheme URTDCM, which was implemented by government of India, actually POSOCO or Grid India, that the company was looking for that, and they have planned to install more than 1500 PMUs in all the five regions of our grids, starting from northern, southern, eastern, western, and northeastern. So they have already implemented 1547 PMUs till now. Still, some of the PMUs they are looking where they are constructing some of the HVDC substations. So PMUs, they are the most vulnerable devices because PMUs are sending their data, let's say, to PDC, higher level, higher as per hierarchy. So usually what is done is that 8 to 10 PMUs from one region, they are going to send the data to one PDC. So 8 to 10 PMUs are there. One PMU, let's say in one substation, you have three incoming feeders, three outgoing feeders. One each is let's say taking data of three currents, three voltage. So six datas are there and six feeders are there. So 36 data that is taken by one PMU, and multiply by, let's say, 8 or 10 PMUs, those data that is received by PDC, and this PMU is sending the data to PDC using some protocols or standards, right, which was discussed by Professor Sidhu later on, and that standard is IEEE C37.118. So there are certain standard, means there are certain protocols, like we are writing codes in C++ or Python or Java. So there are certain fixed scripts available. Based on that, they are sending the data. All PMUs are sending data to PDC. Now this PMU, and whenever PMU sends the data, they sends the data through some, let's say, routers or network switch. So attacker can easily attack on this pilot wire or communication medium very easily, right? Either it is wired or maybe wireless. Usually when long distances are there, the data are transferred through the optical fiber cables. And if it is, let's say, small distances within, let's say, 5-10 kilometers, then it is sent through Wi-Fi network. It depends, right? It depends on. So PMUs and PDCs are very common at higher level, UHV and EHV level, extra high voltage and ultra high voltage level. Then you have some micro PMUs are there, which was installed at distribution level. So there they are sending the data, and again when they send the data, they have to send the data through the modems, routers, or like that switches. So this switches, any attacker can easily hack it. So and you can manipulate those data. Then USB drive, the person engineer who is working in substation, they are checking the emails, they are using USB drives, so you can easily inject any malware through USB or emails. Smart meters are there. Of course, for smart meters, the protocols are entirely different, right? There are several protocols. We will see later on what are the protocols they are using for smart meters. So usually nowadays in our country, smart meters are installed at for HT consumers, high tension consumers. These consumers are those consumers who are utilizing three-phase power at 415 volt or higher level. So when, and they have been built by this company, Discom, using two-part tariff. So they have the normal, our, as we are paying the bills, we have the block rate tariff, where we have the number of units consumed multiplied by the time, right, hours. So there the company, they are having the two-part tariff. There they have this running cost, how many units they have consumed multiplied by the hours, plus some fixed cost, right? So it is fixed cost is calculated based on the contract demand. They call it contract demand. Let's say if one company is there, for example, our IIT Roorkee, we have a contract demand of 1 megawatt, right? So for 1 megawatt per kVA, whatever is the amount which is fixed by IIT Roorkee and utility, UPCL in our case, Uttarakhand Power Corporation Limited. So that amount is fixed, let's say per kVA some rupees, let's say 5 rupees or 10 rupees, multiply by 1 megawatt, convert in kVA. So that much amount you have to pay every month, right? That is fixed cost. Whether you consumed any unit, whether you consume more units or less unit, this much amount you have to pay it by any cost, right? So that is also done for all the industrial consumers, right? HT consumers we call it. For LT consumers, we don't have smart meters. We do have, but the when you go and try to install the smart meters in villages, usually they send the docs, right? They don't they resist, right? They don't allow you to install the smart meters, right? For the engineers. So still we have not installed, but in some of the regions, right? Let's say in western region of our country, where they have already installed the smart meters and they are taking the data for domestic and residential consumers, they are taking the data. So when you take the data, there also the of course the standards are different, protocols are different, but again the data you have to send through some routers or some gateway, so their attacker can easily attack it. Then we have the DERs. You know that renewable energy sources are there, and government is encouraging, let's say in our country, specifically wind and solar, photovoltaic solar. So there also this photovoltaic and wind-based resources, they are also sending the data, right, to the discoms. So there, when they, of course, their protocols are also different, right, different than the smart meters. But when they send the data, there also they are sending the data through some routers or switches like that or gateway. So their attacker can easily hack it and manipulate the data also, right? So that is also there. uh, we have still computer server, we have some data storage. For example, at distribution level, when the discom is there, when they are getting the data from all the HT consumers, industrial consumers, commercial consumers are also there, like the malls and all. So they are also having the sending the data to the discom. And discom, they have the separate unit, it is known as meter energy management device, right? So there they are collecting the data. So there also data storage is there. There also any attacker can hack those data, right? So that is also. And of course the communication network. So communication network, we know we are using different types of communication network, Wi-Fi, maybe Zigbee or 4G, 5G, even further, LoRaWAN, anything, or maybe wired, conventional one, or the fiber optic cable, or maybe GPS. So the of course the protocols of this wired and Wi-Fi are different, but attackers are same, right? So if you have a skilled knowledge how to just do the hack or attack on the system, then you can easily hack it and you can easily manipulate those data. So all these are the vectors where one can all these devices are vulnerable for the attack, and one can easily carry out the attack on this. Now, when you transfer or when you send the data, right, from, let's say, one smart meter or smart device, send the data from, let's say, one device to another device, one meter to another meter, then those data are transferred through several layers, right? There are layers. So obviously we know that the normal what we can understand are the layers are hardware layer, software layers, firmware layers, and the network layer. So these are the main four layers, right? Where, so hardware layer means it is a layer where you are trying to control your hardware devices, right? Whatever hardware device, let's say you install PMU, you install relay, you install RTU, remote terminal unit, or you install smart meter, so it's your hardware device, right? And you have to control that hardware device using some software, right? So this layer, that is hardware layer, is controlled by software. Some software is there. You know that when any smart device is there, by default some software is there which is going to run that hardware devices, right? So some of the informations are there, like PLC, RTU, or any other smart device, IEDs. So those are going to send or controlled by some software. So the firmware layer is a layer which resides between the hardware layer and software layer. So we know that we have one smart meter which is controlled by the dedicated software, right, which is given by that manufacturer of that smart meter. So that software is going to control the your smart meter, which is a hardware device, and firmware layer is between the hardware layer and software layer, right? So what is firmware layer? Where you are going to install several instructions, right? How your hardware works, right? What are the syntax? What are the backups available? What are the inputs and output units? What are the contacts? All those things are, all such type of instructions are there in the firmware layer, right? And third one, that is the software layer. So we know that many software layers are, or softwares are available through various platforms by the manufacturer to control your hardware device. So one can have the let's say hacking of the your software platforms or device also, but they can do only the coding errors, right? There is not much to be done on the software part. If you, let's say, do some hacking for software, one can easily remove it and reinstall it. There is no issue. But the major issue comes where the all the your data which is processed from software to hardware layer and comes to the network layer. So the main main problem starts from the your our network layer. So network layer, when any device is there, several devices are there in the grid, electric grid, then there are various ways like firewalls we use modems, we use a field bus network, we use the communication systems and routers, we use gateways, we use remote access points and protocols and control network. So all this whatever data we are transferring, all this data that is transferred through network layer, and the attacker, they are trying to have the attack on this network layer instead of doing attack on hardware layer, software layer, and firmware layer. So they are trying to have the attack on the network layer itself, right? And of course process layer is there, but it has no way. Now what government is doing, right? Just hurriedly. So government was started, they came with the IT Act number 21, started in 2008, and they form a company in 2014. It is known as National Critical Information Infrastructure Protection Center, known as NCIIPC. So it was established in 2014 by IT Act 70A. Now this NCIIPC is going to deal with two important aspects. One is they are going to prepare the guidelines for protection and critical infrastructure of our country. And second, they are going to prepare also a framework for evaluation of cyber security in our country. Before 2014, there was no framework. That's why government has started, established this NCIIPC. Later on, after 2014, in 2015, government has also established form Indian Smart Grid Forum, because we entered in the microgrid and nanogrid era. So Indian Smart Grid Forum was established in 2015, and later on in 21, CEA, that is Central Electricity Authority, they have also given the guidelines for cyber security of power sector, right, for which we are looking today all the lectures and the laboratory sessions. So that was based on the cyber security of the power sector or electric grid, which was started by CEA in our country in 2021. Then government has also started one company known as 13. It is the Computer Emergency Response Team. It is known as 13. uh, this is going to respond the computer security incidents, reports the vulnerability. That's why you know that nowadays in all these states, government has planned, is formed, let's say, separate cyber crime unit, and they are also let's say displaying the numbers and all that, If any cyber crime is there, then you can report it immediately, right? So that that team can have the further processing of that. So that team of every state, right, cyber crime cell, that works under this team, right, which was established by government. Then we have several standards also, which was taken by the industry working in our country, like ISO 27001 in 2005, very old. It was related to security management system. Then our government has also amended our electricity grid codes, clause number specifically 4.6.5, which was related to this cyber security clause. So then they have mandated that all the utilities, all discoms of the states, and all the grids, SLDC, RLDC, right? All they have the cyber security framework. They have to establish that. Still, some of them they have established, some of them they have not established. Then the further in 2015, the industry has acquired the IS 16335. This was related to the protection of critical assets of the all the entities involved in generation, transmission, and distribution. So there they have given the guidelines. And then finally, CEA, as I told you, Central Electricity Authority, which works under the Central Energy Regulatory Commission, CERC. They have given the regulations in 2016. They started, and recently in 24 only CEA has completed. So this they have formulate and notify the technical standards which CEA has done recently. Cyber security requirements for all the, let's say, private and public power producers. So these guidelines also CEA has given nowadays, and protocols for communication system, right, for power sector, public and private both. So this has also given by the CEA recently in to end of December 2024 and 2025. Now, with this background, let us see what are the key areas where one has to look, right? Because we believe that cyber security means, let's say, cyber security of power system or like that. It's not like that. So I have listed here 12 areas where one can look at, right? You can go through the papers and all. So first area is related to the cyber security and privacy. So here, as I told you, privacy means privacy is related to the data which was sent by the smart meters from one end to another end. We have number of millions of consumers where smart meters have been installed, and the data which are generated by the higher entities like, let's say, transmission company or public or private power producers. We have to secure those data which was used for billing purpose or maybe for certain market related operations, energy related, energy trading and all. Because now we have private power producers also like Adani and Reliance, and protection against various attacks, right? So those are one of the areas where one can look at it. Then you can also consider the areas where you can work on the securing your programming part, software part, instead of working on the protocols or the communication where the data has been transferred. One can work on communication part. So maybe software part, where you have to develop some algorithms, right, robust, which is robust against all types of cyber threats and attack, so that you can develop, like for example, you develop the algorithms for protection purpose, like let's say phasor estimation algorithm is the best example, where you can convert all the continuous or instantaneous values into the phasor values. So that algorithm you can secure that none of the attacker can attack on that. Maybe you can develop the algorithms for, let's say, PLC, SCADA, or RTUs also. So those comes under the regular operation of the power system network. Then one can work on protocols. So protocols is also a separate area where one can work. For example, we are using DNP3 protocols, distributed network protocol. We are using SCADA based, let's say, protocols. We are using AMI, advanced metering infrastructure, smart meters related protocols, IEC 61850, and several other protocols we are following for distributed energy resources, that is the renewables, solars and wind. So there the objective is you have to let's say create interoperability, and even any device you install, it can work on any protocols, right? It is not that okay, I have installed one meter, it is only compatible with a particular standard only. No, it is not like that. For example, best example is our EV system, right? You know, our electric vehicle systems, we are using the OCPP protocols, open charge point protocol. So it's a protocol when you connect your electric vehicle at the charging station, from backend side, your electric vehicle station equipment, he is going that equipment is going to communicate with your devices, all the charging devices, right? So that protocol is created by I think by Netherlands, if I not mistaken. It was created by Dutch company in 2006, amended in recently 2015, later on 21 also. So there it's a open source, right? And so whatever type of charger you have, irrespective of the company, right, it is going to follow this OCPP protocol. So same way here also, whatever type of meters you have, whatever type of PMU you have, it is compatible with all types of protocols, right? That is there. And this all these protocols are not vulnerable against a different type of attack vectors like spoofing, manipulating, time related attacks, and several other attacks. So you have to create the system which is resilient in nature, and which can support our smart grid system. Then fourth is related to the information theory and cryptography. This is also a different area, right? One cannot work in all the areas. So here the issues are related to the encryption and decryption part. Because here why this area comes in picture, because whenever any device, let's say smart meter, is going to send the data to another meter, so this data is not going to send as it is, right? So what they are doing is that whenever the data is sent by smart meter to another smart meter, they are going to encrypt it, and the receiving meter or receiving device, that device is going to further decrypt it. So there so this is done just to increase the security part. But now hackers are very smart. They have all the encryption and decryption software also. They have made the algorithms also. So one can easily let's say encrypt and decrypt it very easily, right? So this is also another area where, and the targeted let's say the devices are smart meters where encryption and decryptions are required. Our DER controllers, where you are using the controllers for the photovoltaic sources or wind sources, there we are using controllers. We are using primary control, secondary control, or further tertiary control also. So there all the inverters are there. There also you have to consider this cryptography or encryption and decryption process. So it is a separate area. And then finally you have to analyze the privacy and secrecy to evaluate the sensitive information, so that the attacker cannot hack it. The next is the related to the blockchain technology. So this is also entirely a different area of cyber security, where the important task is related to our EVs. Now you know that when we are talking about EVs right now, the OCCP 1.5 or 1.6 protocol is running. But nowadays, the agency has also given the guidelines for next generation protocol 2.0. I think they have already approved it. Now they are trying to, why they have changed from 1.6 to 2.0 for EVs. The reason is cyber security aspects, right? They have observed that. You can find a report through Google. Siemens has done this analysis. Whatever current protocol we are having for EVs in our country or even in other countries also, they are not cyber resilient. So one can easily attack on whenever you connect your device. Obviously they are trying to have the IP address and some other data, what is the state of charge of your vehicle, accordingly charging of the vehicle, that is to be done. right? So there, the attacker can easily have the attack on these systems. So they want to make it foolproof. That's why they are moving ahead from this recent protocol to the next one protocol. Uh, so here in blockchain technologies, the idea is to develop the peer to related to peer trading, EV charging, and related to the issues related to the markets. And then we have the forensic and computer software security. So here you want to try to identify, collect and analyze the digital evidence, right? Because whenever any attack is there, then you have to do the post-mortem analysis. So there you need all these things, right? The whatever the digital evidence from one device to another device, one point to another point. So every point you need this type of system. So that's why it comes under this area. This is also entirely different area. The other areas are related to the power, producing of power, generation of the electricity. There we have to secure our SCADA system, which works under DNP3 protocol. Our distributed control system is also there. And the protocols they are mainly using, that is Modbus or TCP and IEC 60870-5. So this is the protocol that is used by most of the power producing companies. So there the key device to secure are the controllers, turbine controllers, the excitation control units, the plant PLCs, and HMI or the SCADA servers. So all these things we need to secure. So one can also look at to work in this area also. The next is transmission sector. There where all the data when power is generated, then the data that is transferred by PMUs and IEDs from one end to another end. So peer-to-peer communication between PMU and PDC, secure SCADA communication, and the protocols they are using, that is 61850, basically the goose and sample value based protocols. IEEE C37.118, which is a protocol for communication between PMU and PDC, and DNP3, which is used by SCADA system. And the key devices we have to use, that is PMU, PDC, relays, PACs, controllers, and RTUs. So these are the devices where we have to consider the cyber security aspects based on these protocols. Then we have the smart grid, where we are looking about microgrid and the other systems. So here there is a two-way communication between any of the devices which you have installed in microgrid. Here the protocols used are the DLMS or the COSM, ZigBee type of smart energy systems that is also used. And the key devices which we need to consider, that is the smart inverters, the home energy routers, IoT sensors, and the AMI, that is advanced metering infrastructure based meters. So all these four devices we need to consider for resiliency purpose, because they are using these two protocols, right? Of course, some other protocols are also there that we will discuss later on. For DC microgrids also nowadays HVDC systems are also coming. So there also they are using IC 61850 and Modbus type of protocol. And there we have to consider the local controllers, renewable sources, and storage, obviously energy storage also. So all these things we have to look at. And the major threat against all this HVDC part, that is the false data injection attacks. So this type of attack, false data injection, they try to manipulate the data very let's say intelligently. They don't try to randomize the data, but they try to change the data intelligently, so that the some of the whatever the prerequisites are there, they need to be followed. So we do not know that now the data have been manipulated. It is not like that. And the key devices we need to secure is the microgrid controllers, central plus local controllers, DC to DC converters, and the charge controllers. So this comes under the microgrid part. Then we have the resiliency part of our main central system where the servers and the our main computers are there. So all the AI or ML or statistical based algorithms are installed. So there those servers also we need to secure. And these servers are used for, let's say, state estimation purpose, or maybe for the some management, data management purpose. Even here also the wide area communication concept also they are trying to implement it. So that also we need to let's say consider it against all type of cyber attacks. We do have the distributed energy resources, all the renewables type of sources are there, and they are also involved now because government is encouraging to install such type of renewable sources. They use the protocols like IEEE 2030.5, widely known as SAP2, DNP3.SA for DR integration with our grid at point of common coupling, and SunSpec Modbus type of protocols are also used by some of the utilities. And key devices we need to secure, that is our solar inverters or wind inverters, battery energy management system, and our DER servers, right, who is going to dispatch or aggregate the final outcome. So this is also there. HVDC, long or large distance HVDC systems are there. So that also we need to secure it, because in HVDC part most of the communication takes place, and most of the protection systems are based on differential protection. So they are trying to send the data locally as well as from one substation to another substation, rectifier to inverter substation, through some softwares, some protocols. And these protocols are 61850 and IC 104. IC 104 is used for monitoring purpose, 61850 that is used for protection and control purpose. And the key devices in HVDC substation we need to secure, that is VSC or CSC converters. We do have DC relays, protection relays, and converter station local PLCs. So this also we need to secure it against all types of attacks. So this is also entirely a different area. And last area, that is the charging stations, our where electric vehicles comes in picture. So as I told you, we are using different types of protocols. Right now we are using OCPP 1.6, but later on recently they have given 2.0.1. We are also using ISO 15118 for plug and charge. We are also using 63110 protocol also, and we are also using Modbus, right, for charging control purpose. And the key aspects: EV chargers, all types of AC and DC chargers, charging management system, and V2G inverters. So all these area devices are targeted by attackers using these protocols, because in these protocols, if you look at there is no cyber security aspects are covered. So one can easily do the attack on this and manipulate the data. So thank you. I think let us have the, if you have any questions, then uh, I'm happy to answer. This is the very fundamental things. I thought before Professor Sidhu starts the protocol part, I have to cover few things which is very important part. So any questions?